The first thing that I want to start with is we want to give you a quick overview of what we will be covering in this webinar. First, we're going to give you a short definition of quantitative reasoning. And then we'll talk about how quantitative reasoning is situated in every degree program at Walden. Sarah, our second presenter, will follow that with some details about descriptive statistics, and she will include some examples in specific fields of study. I will then come back to you to talk about the next level of statistics, inferential statistics, where we will talk a little bit about the testing of hypotheses. And we will again explain that with a couple of examples. It might be interesting to you, as Sean said, to know that we are all dissertation students, and we will give you the examples of our actual dissertation work. We will then spend a moment to address the P and the alpha values as well, which are such an intricate part of hypothesis testing. And Michael, who is our excellent biostatistics tutor, will present the in and outs of biostatistics, and he will offer a fairly current example of the odds ratio. We will conclude the presentation by looking at the application of statistics in the real world, when we will also give you a chance to let us know if you are actually using statistics in your workplace. Our total presentation will run about 30 minutes, and that will leave us generous time to address any questions you may have. As you can see on the screen, quantitative reasoning is a process. You will be applying basic skills such as statistics to address an existing program. To address an existing problem that you would formulate in a research question, and that you would then analyze with statistics. It will exist of real-world quantitative information that we call data, and you would interpret that to draw relevant conclusions. And since we are a social change university, your interpretations are most of the time in a context of social change. Now, of course, Walden covers all levels of degrees, and we offer undergraduate and graduate degrees, such as master's and doctorate degrees. And I'm pretty sure we'll probably have people from across the 3 degree levels. As a matter of fact, Sean has created a little poll for us that you can use to share your degree level with us. Sean, would you mind pulling up that poll for us? There are 3 different answers possible. And please use one box when you fill it out. And if you like, you can also tell us in the chat box what kind of subject you're studying and what specialization you've chosen. We'll give you a moment to fill out the poll. Nearly 95% of our audience are doctoral programs, which does not surprise me because we do get a lot of doctoral programs for our tutoring services. But I'm surprised to see that we do not have any bachelor students. Quantitative reasoning skills are paramount and required at every degree level at Walden University. It doesn't matter whether you are an undergraduate, master's, or a doctoral student. At one point or another, you will be asked to apply statistics skills towards quantitative reasoning. At that time, you will probably be in a statistics course. That's where you will be introduced to quantitative reasoning, and you'll be asked to apply statistics to analyze a data set, formulate a research problem, and interpret statistic results to draw relevant conclusions. For most of you who are in the doctoral program, that would require SPSS to execute your data analysis, but you might also have some rare courses where Excel is used for the data analysis. For the undergraduate level, you would be introduced to StatDisk, but undergrads are also sometimes asked to use SPSS for data analysis. Earlier, when I mentioned quantitative reasoning, I gave you the process. And as a Walden student, when you are introduced to statistics, you will, for the most part, be using secondary data sets. Those are data sets that are produced by somebody else that you are then using to articulate a different research question. At the doctoral level, that is a little bit different. There it's just a question of what approach you take. If you go and collect your own data, you would then produce a primary data set. And if you would use a secondary data set then that has been produced by another researcher, most likely for another study or in a general context, and that you will then apply to your research question. The analysis of data always starts with description of data. That is where you describe your sample size, your variables, you produce frequency tables and graphs. And I will now turn it over to Tara, who will talk a bit more about the use of descriptive statistics. Tara, take it away.
Again, I am Tara Garrison, and I am from Virginia. I'm going to talk about basic descriptive statistics, population, sample, unit of analysis, levels of measurement, frequency tables, and other verbiage that you'll see a lot in statistics. In the field of statistics involves methods for describing data analysis, data. Descriptive statistics also enables researchers to summarize and organize data in a meaningful way. This means that they take jumbles and jumbles of numbers and make it something that is meaningful for the population who reads it. For example, descriptive statistics can tell a researcher the average or mean of a data set. Most of us in here, we know what the average numbers are and how to get to that. But it can also inform us about the frequency of data. So one of the things to describe about data is the population. In population defined is the complete set of relevant data and includes all possible units that have value for that specific insight. And when we talk about a population, we don't always mean a specific population of people. This can also include groups, objects, events, documents, procedures, treatment programs. But of course, in the real world, it's not always possible to get insight on a complete population. That would be too time-consuming and probably very expensive. Therefore, we take a piece of the population, and that's also called a sample. And we do that in a representative way to make sure that our results can be generalized across the population. Let's give an example here. A sample analysis of the age of homeless men and women in one specific region of the U.S. may well be considered representative of a total group or population of homeless men and women across the United States. We could not generally take a group of homeless men and women, let's say on your street, USA, and consider that a generalized assumption for that whole group. We have to have something a little bit larger. Now, in statistics, we also have a term that's the ever-present part of the process of quantitative reasoning. It's called a variable. A variable is something that can be identified and measured. Examples of variables are gender, height, weight, ethnicity, attitudes, etc. But variables are broken up into two main groups. One is a dependent variable, and the other is an independent variable. A dependent variable represents the change a researcher hypothesizes to explain, while an independent variable explains the changes in the dependent variable. I would like to illustrate that difference with a quick example, and feel free to chime in the text box, chat box. Can anyone identify the independent and dependent variables in this example? What is the effect that water and sunlight have on plant growth? See some answers here. I'll read it one more time to you so you make sure you get it. Okay, what is the effect that water and sunlight have on plant growth? Oh, look, I'm starting to see correct answers in here. Indeed, you are right when you choose plant growth as your dependent variable. And why is that? Because water and sunlight, also known as your independent variables, change or alter the dependent variable. In this example, you take away water, your plant may not grow the same. Or sun, your plant may not bloom at the end of the day. And another distinction we have between variables lies in a level of measurement. That is the classification that describes the nature of information within the numbers assigned to variables. There are two overarching groups recognizable in the levels of measurement. One is called categorical variables and continuous variables. The categorical variables are nominal and ordinal. Nominal variables could simply be called labels. Like nominal, we could always say the word name. Some good examples of a nominal variable are as far as gender, male or female, where a person lives, northern or southern United States, or a color of a person's eyes, blue, green, or brown. A good way to remember all of this, again, is that when you say the word nominal, it sounds like the word name. The next level of measurement is the ordinal variable. These are typically measures of non-numeric concepts, such as satisfaction, happiness, discomfort, and so on. What sets ordinal variables apart from nominal variables is they are groups that can be put in a certain order. For example, if we take clothing sizes, you have sizes such as small, medium, large, and extra large. All of these are four distinctly different levels that can be ordered in some logical way. As I mentioned earlier, the second overarching group of variables are the continuous variables. There we will find the interval and a ratio variable. The classic example of an interval scale is like temperature that can be measured in Celsius or Fahrenheit. Both can be measured and a meaning can be attached to these values on the scale. Each point on the scale has a constant distance to the previous or next measurement, but each are missing a definite 0 point, which makes it called an interval variable. Now, when a variable is measured at the highest level of measurement, we call that a ratio variable, which means it has an unambiguous level of 0. An example of this, age. Age is a ratio variable, and so is mass, length, duration, energy, and so on. All of these examples have a meaningful yet unique and non-arbitrary 0 value. Lastly, much of the data discussed above can be visualized through frequency distribution graphs. These are visual displays that organize and present frequency counts so that the information can be interpreted more easily. A frequency distribution of data can be shown in a table or graph. Some common methods of showing frequency distributions include frequency tables, histograms, or charts. The appropriate display for a variable relates directly to how you measure that variable, such as pie and bar charts are usually used for categorical variables, nominal and ordinal, while a histogram, scatter plot, or a line graph is more appropriate for a continuous variable, such as interval and ratio. Now we can move here to slide 9. And we got examples of descriptive statistics. In human services, to use descriptive statistics, we would maybe look at participation rate for counseling services. As far as health services goes, we may use prevalence as a measure of the frequency or mode of a disease in a population. And if we look at public policy, understanding election results, mean versus standard deviation. All right, and on this, I am going to slide this next section right over to Janine.
I want to thank Tara for that informative presentation on descriptive statistics. As Tara explained, descriptive statistics are used to provide details about groups of data so that we can understand what the variables are, how they act, what they measure. But now I'd like to talk about the next level of quantitative reasoning, and that is inferential statistics. Inferential statistics elevates the analysis of data to the next level, and it uses techniques to draw samples and then explore those samples in a bit more detail. It's important to note that before you can analyze the data, you would have to formulate a research question. That would be your problem statement, but in statistics we call it a research question that you're hoping to answer. That research question would then be translated into a testable hypothesis. That hypothesis is called the null hypothesis. We also articulate the alternate hypothesis, but that's not the one we're testing. We're only testing the null hypothesis. A null hypothesis is articulated in a specific way. It's usually articulated negatively, like it might include the word no or not. It would definitely include the variables that you're trying to test, and it will give some kind of reference to a test that you're using. And to illustrate that, we're going to give you a couple of examples. And like I promised you before, these are straight pulled out of our dissertations, so it gives you a sense of, how students might apply these tests in the actual work that they're doing. Sarah, I'm going to give it back to you to talk about your dissertation a bit.
Okay, thank you, Janine. Again, my level is in human services, and I am at the chapter 3, going on to my first defense of my dissertation. Now, my research question is, what is the nature of the relationship between media consumption, social response, attitudes, demographic factors, and attitudes towards police as a result of police-initiated violence actions upon citizens? In my example, my null hypothesis would state that there is no relationship, and I will test this using a multiple regression.
Thank you, Tara. Now I would like to give the microphone to Michael to talk about his dissertation subject for a bit. Take it away, Michael.
Thank you, Janine. So right now I am on my first step of a dissertation. I am working on my perspectives. And my research question right now is there a relationship between the specialty of physicians and medical malpractice cases in Puerto Rico? So in this case, my null hypothesis will state that there is no relationship between the specialty of the physicians and the malpractice cases in Puerto Rico. So I will test that by conducting correlation and regression analysis.
Thank you, Michael. Thank you for sharing your dissertation subject with us. It's interesting to note that between the three of us, we're all at a different stage of our dissertation. As Tara mentioned, she's currently writing chapter 3. Michael has recently started the process and is working on his perspectives. And I'm actually working on chapter 4, so I've put the proposal stage behind me, and I'm now struggling through the statistical work. And I can share my dissertation subject with you to give you an example of an inferential test. I am studying in the field of public policy, and I'm interested in understanding the differences between the refugee policies in Canada and the United States. We know that they're implemented in very different ways, and to get an idea of what might not exactly cause, but what might lead to those differences, I'm looking at the effect of the media, specifically how the media in Canada and the United States portrays the subject of refugees. And for that, I'm testing a null hypothesis. I have about 7 null hypotheses, but I'll give you one. And it goes like this. In Canada and the United States, newspapers project a similar tone in articles that address the subject of refugees. Now, obviously, I'm looking for differences, so that would point to a compare means test. And in my case, I'm looking for a t-test, but with a covariate attached, which turns it into an ANCOVA. So I hope you enjoyed these examples of actual dissertations. Now that we know how quantitative reasoning works and that it's the null hypothesis that is being tested, we will introduce the concept of confidence intervals. Just to make clear that in statistics we are not proving anything, we're merely trying to stay within a certain level of confidence. In the field of social sciences, we work with a 95% confidence interval, which leaves us a 0.05 or 5% chance that we are going to make a mistake, and that is called the golden rule. That is the golden standard. That alpha level of 0.05 represents the chance that we're accidentally rejecting the null hypothesis while it's valid. And since we want to stay within those boundaries of 5%, we will, let me check this, we only reject the null hypothesis when that p-value that SPSS gives you is smaller than alpha. There are other fields where the alpha level might be set slightly different. For instance, in the medical field, it's a bit tighter. It's set at 1%, but that's because the results of research can induce life and death decisions when you're talking about medication or testing treatment. There's also the possibility that the confidence interval is set at 90%, which allows a 10% of making a mistake, 10% of alpha. That is generally only accepted when it's a truly exploratory study, and those are very rare and few between. To my knowledge, students that are working at the dissertation stage at Walden and who have selected a quantitative methodology are expected to evaluate the p-value against alpha of 0.05. I'm not sure, maybe Michael and Tara have a different experience there, but that is my understanding.
Yes, normally when you're working in clinical research, we use the 0.01 instead of the 0.05, because when you're working with some medications, you are working with people's lives. So if your drug doesn't work really well, you might kill a lot of people. So that's why we keep a tighter alpha values in our field.
That's interesting, Michael. Thanks for sharing that. That gives us a bit of an idea of what it means, really, to have that alpha level set at a certain value. So now that we have a better idea of what inferential statistics is and we saw how we can test hypotheses in statistics, I'm turning it over to Michael, who will present insights into biostatistics. Go ahead, Michael.
Thank you, Janine. So hello everyone, my name is Dr. Michael Gomez and I am from Puerto Rico as well. I see a couple of you from Puerto Rico too. So let's start now by understanding what is biostatistics. So basically, it's using the tools of statistics by answering research questions in medicine, biology, and public health. Such questions could be whether a new drug works, what causes cancer and other diseases, and how long a person with certain illness is likely to survive. In recent years, the health sciences have become increasingly quantitative. Some of the health science disciplines that are noteworthy in their use of statistics include public health by using biostatistics, in epidemiology, health education, and environmental health, in medicine that we use in biometry, in preventive medicine and clinical trials, in nursing research, and in healthcare administration that we use it a lot for operations research and needs assessment. So technically, you can apply this to any field in the life sciences by using similar statistical tests such as t-tests, regressions, and ANOVA. The main change here is that with science statistics, the origin of the data and its interpretation. At research level, statisticians tend to be more interested in developing new methods and theories to support them, whereas biostatisticians tend to be more interested in applying existing methods to existing methods to new biological problems. There is definitely a fine line in some cases, but in general that's a distinction. So now I will explain to you. Oh, okay, perfect. So I will explain you now an example in my field. In 2011, I went to work with the National Science Foundation through a scientific campaign in Russia to study global warming in the polar regions. So when I conducted the global warming analysis in Russia, we conducted many regressions analyses with multiple variables such as CO2 concentration and pH. Also, we used regressions to create models of how the frozen ground, that is called permafrost, is melting in those areas, so we could predict future concentrations of CO2 in our atmosphere. In this experiment, we concluded that in the next 50 years, we will have 3 times the CO2 that we have right now in the atmosphere. So it will increase by 3 times. So that's how you can apply biostatistics in the real world. So, as a biostatistics student, you will learn that quantitative reasoning applied to the field is applied frequently to the fields in medicine, biology, and public health, and we calculate some values, for example, the risk ratios and the odds ratios. For instance, you might learn about the risk of a specific disease in exposed individuals to the risk of disease on non-exposed individuals. The odds ratio, a value that also has a distinct place in logistic regression, is often used as a measure of association in both case control and cohort studies. So how in the screen we have an example that is considered a classic odds ratio situation. In this case, the purpose of the exercise is to evaluate the relationship between vaccination and the risk of autism to see if there is merit to that relationship. To get this result, we will multiply the number of persons with autism who were vaccinated by the numbers of persons without autism that were not vaccinated. Then we divide that product by the number of individuals with autism that were not vaccinated multiplied by the number of individuals with autism that were vaccinated. That little calculation gives us the odds ratio that has a unique way for interpretation. When the odds ratio is 1, exposure to the vaccine will not affect the odds of autism. If the odds ratio is greater than 1, the exposure to the vaccine is associated with the higher risk of autism. And if the odds ratio is less than 1, exposure to vaccines is associated with lower odds of autism. Since we know that from existing research that there is no relationship between vaccines and autism, we can say that the odds ratio in the real world will be around 1. So this completes my biostatistics presentation. So I will give it back to Janine now, and she will tell us about the statistics in the real world.
Thank you, Michael. And thank you for giving us that example of autism and vaccines. It's a very current example. And for those of you in the doctoral program who are in some course of public health, you'll be sure to run into this example because as far as I've seen as a tutor, it shows up in nearly every public health course. So thank you for that. Now, we have a couple of minutes left to talk about statistics in the real world. I know that most of you are in the doctoral program, so you probably had exposure already to statistics, but I'm curious to see how you experience that in your workplace. So for that, Sean has been so kind to create another poll for us. Thank you, Sean, for bringing that up. Now, this is a very easy poll. You are either aware of statistics at your work or you're not. Let's see how many of you are exposed. There you go. 95%, thereabouts. Give you one more moment. 76%. Okay, let's call it a 78. We're going up. 25% do not use statistics at work or are not exposed to it, and about 75% of you guys are. Now, statistics is just all around us. There is no public policy decision or decision at higher levels that doesn't involve some kind of research that backs that and some kind of result that was statistically deducted. And that's the kind of experiences you get when you enter your statistics courses, you'll see that it has real life applications, and you will learn as a researcher to apply that as well, to get yourself through the process of quantitative reasoning that you will definitely use at the doctoral level if you choose a quantitative research method. With that, our presentation has come to an end, but we certainly have some time for your questions. And Tara and Michael, Terry, would you like to answer some questions?
Yeah, sure. Okay, if you have any questions for me, just put them in the chat box, and I will answer them as fast as I possibly can. All right, I got a question here. Second, and pull my screen up a little bigger. And she asks a good question. She asks, how do you determine the instrument of measure? And I want to say thank you, Valentine, for that question. You got to pick how to know which measure you're going to use. It really all depends on the variable itself. Like we had said earlier in our presentation, that, like nominal variables, for example, something that's related to a name. When you think of gender, male or female, where someone lives, the color of someone's eyes, things of that nature, and that's kind of considered a label. So we call those nominal, and they'll always be nominal variables. Just the same as ordinal variables for sizes of clothes. All of those things fall into those categories. And the more you learn into statistics, the more familiar you'll become with these. Janine, is there anything extra on that?
No, I think you've covered it. The only thing that you want to make sure is when you select an instrument for measurement, it has to be validated. It's like, standing on the scale in the morning. If your scale is not set to 0 before you step on, then you're not going to get accurate results. So the validation process for instruments is usually something that is done by other researchers if you borrow or, buy an instrument from other researchers. But if you develop or even change an existing instrument, you would have to go through a process of validation. And I can tell you from firsthand experience with my dissertation study, that is not always the easiest route to take. Sometimes it makes sense. If there is an existing instrument to measure something, then I can only recommend you use that. And for more information on that, our Center for Research Quality can help you with that, and they have resources on that as well. So don't hesitate to reach out to the CRQ or even to our services, and we can direct you to the right place for that answer. We have one question about recommendation for a good book of statistics.
Yeah, I think I answered, and I told them that I use a multiple array of sources. So this really depends on really the teacher. If it's outside of the classroom, I have a 1988 copy of a Cohen and Cohen book on multiple regression. This is like my right hand. My other biggest book I think I use is one I took in the very early parts of my PhD, which was the basic research methods in social sciences. I always go back and forth to that one.
You're talking about the Creswell book?
This one is Frankfurt Nachmius and Nachmius.
Oh, Nachmius. Yes. Mm-hmm. Yes. I'm not sure if that book still makes an appearance in the statistics courses. Once in a while, they get replaced with maybe more recent copies. But yeah, as far as the resources are concerned, I think the best starting point for you is within the resources of the course. And of course, you can always ask your instructor if you have a need for additional resources. And as tutors, we get that question too. And if there are areas where you would like some more resources or a greater understanding, by all means, you can always come and ask the tutors, and we'll direct you in the right direction.
I think I got a question here. This is a pretty good question. I have Valentine asked another good question. Can the independent variable and the dependent variable be reversed? Well, that really depends. How do I say this? You got your dependent variable, and then you have an independent. And unless a dependent variable causes, it's not possible that a dependent variable would cause a change in an independent variable, if that makes any sense to you. Say if we talk about the flower plant growth again, plant growth, which was the dependent variable, cannot possibly impact the sun or the rain. So in that example, you can't reverse them. You just cannot do it. I hope that kind of answers your question.
It all depends how you've defined that variable in your research question. It's very well possible that Tara's example of plant growth as a dependent variable is used by another researcher as an independent variable. For instance, if I want to compare plant growth on 2 different continents, then it could be handled differently. Or if I want to find the relationship between how much you water and how much your plants grow, it all depends on the definition of your research question. The way you formulate your research question will determine what your variables are, and it will also determine what kind of tests you run. And even before that, it will be a determinant for the choice between quantitative and qualitative, between the quantitative and the qualitative methodology. So your research question is the key here, and it creates your roadmap for your dissertation.
I see one more good one over here. Emmanuel asks, can we have more than one dependent variable? In my experiences, if you have more than one dependent variable, then you've probably not identified or properly dealt with your control variables. Dependent variables are changes that occur due to the independent variables. Janine or Michael, do you know of any instances where?
Yes, I have a couple of examples in my field. For example, if you give a drug to a patient and you're looking then the effect of that drug in the patient, you can make some labs and you can see the result in some labs. You can measure also the weight of the patient. You can measure different values. So yes, you can have more than one dependent variable for one experiment because it will change. But you will need different research questions then.
Indeed, Michael, I agree with you. You can have more than one dependent variable. I actually have 4 different dependent variables that are all part of the frame, of the media frame. And so there are specific tests for that. When you get to that level in your dissertation, that will become clear to you. It all depends on how you formulate your research question. Michael is right on the point on that.
And again,
Go ahead.
I was just going to say, me, like I said, me personally, I've never had to deal with it. But then again, it all is based on your research. All 3 of us have had different experiences with it, Emmanuel. I hope that answered your question.
And then I want to close it off with the final question that I see here is, do we make ourselves available to discuss our work in open forums to students? Does that relate to our dissertation work, or does it relate to our work as a tutor? I can answer that from 2 different ways. As dissertation students, of course, we would like to talk about, we love talking about our dissertation, so we take every opportunity we can. And I don't know about Michael and Tara. I've also gone out to a couple of conferences where I've presented the preliminary state of my dissertation. And from a tutor's perspective, yes, we have many options for you guys to come and hear us speak. We offer individual tutoring sessions. We also offer group drop-in sessions. and you're more than welcome to use our services. They are free to you, and we can help you get through your stats classes. And with this, I'd like to thank you all for attending. It was a joy for us to present to you.
Thank you very much, everyone.